Thank you very much for coming and taking your time this evening to come and learn about application security. Um, my name is Sam Stepanian. My colleague Sharif Mansour unfortunately is delayed, and I'll explain to you why. If you're tweeting tonight, the hashtag for the event is #OWASP as usual. So we run these events approximately once every 2 months. Apart from this month, we had 3 events this month. We had the Capture the Flag event on the 9th, and we had the chapter meeting last Thursday, and this is another chapter meeting. And the reason for that is, of course, that last Thursday was a Thanksgiving, so our keynote speaker, Jeff Williams, couldn't be here because he was with his family. But apart from chapter meetings, we also run hackathons, Capture the Flags, Hacker Pub Quiz, which is coming up in January. We also run workshops. So I think there was a question on Twitter about the workshops on OWASP ZAP. Yeah, that's coming up. So we're going to talk with the author of ZAP, Simon Bennett, the project lead, to actually run a workshop for us. Yeah, and this is some of the screenshots from our events. Right, so who is here for the first time? Here. Okay, so for those of you who are here for the first time, somehow you found this event. Okay, if you want to make sure you don't miss the next one, this is what you can do, right? Number one most reliable thing is sign up to the mailing list. It's an old-fashioned way, but at least you will get an email as soon as we announce the event. Another very reliable way is follow us on Twitter and make sure that you switch notifications on. We don't tweet that often, but when we do, it's something important. You can like us on Facebook. We have a Facebook page, and hopefully my mobile phone is now streaming, even though we don't have the tripod. So we also have a Slack channel, and if you need a Slack invite, please come and talk to me because I can give you URL how to join our Slack. The OWASP has a Slack community, and we are #ChapterLondon channel on Slack. We also have a YouTube channel at youtube.com/OWASPLondon. So all our talks are recorded, and video recordings are uploaded to YouTube, so you can watch them at a later date. And of course, we have a web page at mainowasp.org. You can just search for London, you find it. Right. The next potential date is last Thursday of January, so that's 25th of January. So mark this date in your diary. It's provisional, but yeah, that's what the next event is going to be. Right, we're hopefully streaming live because it's mobile phone, which I can't see if it's working or not, which is hopefully it's all working. And yeah, people at home can just tune in to OWASP London Facebook page and to watch the live stream. Now, very important, for the first time, we're doing live Q&A because we have such an important speaker tonight. I'm pretty sure there are going to be lots of questions. So can you please take your smartphones out and go to this URL, slide.do, okay? Right, very important. When you go there, it will ask you what's the hashtag of the event. If you just put OWASP, right, all uppercase, you should see a screen like this, OWASP London questions. And here you can type your question. It will give you a chance to add your name, or if you wish to remain anonymous, it's up to you. But that will be your chance to ask a question while our speakers are presenting. Another thing, last couple of events I did printed agendas. So obviously that killed lots of trees. I apologize. So stop doing the paper-based agendas. However, if you want to look at the agenda and speaker bios, you can download this app called Eventor. Search for it on App Store or Google Play. It looks like this. Lots of colored squares. And again, if you search for OWASP, you'll find this event. And we will find the agenda, and you will find the abstracts of talks tonight, and you will find the speaker biographies and pictures of Jeff and David. Okay, so agenda for tonight. I hope you all had pizza and drinks, and thanks to these sticky labels with our names on, we managed to network and find out who we are, what we do, and what brings us all to OWASP. Right, so after this short talk, hopefully, which I hope will be probably even shorter, Jeff is going to present a talk on can DevSecOps prevent the software apocalypse? Right, so are we all doomed, or is there a hope at the end of the tunnel? We'll find out soon. Then we're going to have a break and have more beer and pizza. And then David is going to present us a talk on the myths and misconceptions about cookies. And when we thought cookies is a secure way of authenticating users, that might not be the case. After this, we're going to have a short wrap up, and we're going to go for more drinks and networking at the pub called the Viaduct. That's an old Victorian pub straight across the road from here. And you just basically exit the building, turn right, cross the road, and you'll see it. Okay, now for those of you who don't know about OWASP, we have 200 chapters all around the world. In the UK, this is where we are. So the Bristol chapter is now watching us live. So Katie Anton is the OWASP chapter leader in Bristol. So hello, Katie. I'm going to wave at her. These guys can see us and they can hear us, right? As you can see, they're all in Just Eat offices. So this is the first time we're attempting this. So Bristol guys are going to get a chance to ask questions, but please do use the online app, slide.do #OWASP to ask your questions to make the process easier. I'll display all the questions on the screen so Jeff and David could answer them. Right, so an important thing about OWASP, we're all volunteers. None of us is paid for any of this. And there's a membership, which you don't have to take, but if you do become a member, we'll appreciate it. The membership is only $50 per year, which is not that much. Apart from this cool sticker that you can collect from me if you're actually a member, you'll get these benefits. And most important one is you'll get exclusive discounts on various application security and cybersecurity conferences happening all around the world. Sometimes it could be 100% discount free, but we have anything from 25% to 75% usually, right? Another advantage, you get an OWASP.org email address, which is kind of cool. And another very important thing, if you're a member and you're paying your $50 a year, you get to vote on OWASP issues which shape the direction of our foundation, right? So we are actually vendor neutral. So you can see lots of logos on the screen. These are all the companies who are corporate members, right? So you can be an individual member, you can be a corporate member. And these companies are what we call premier members. So these are the folks who donate $20,000 per year, right? Recently we had Salesforce and WordTech joining. So thanks very much to them. Now in London, we have our own sponsors. So you can see these are the companies who kindly sponsor our chapter, and some of them provide us with a hosting space, pizza, and beer. And obviously tonight we're at Just Eat, and I'd like to invite Kevin Fielder, the CISO of Just Eat, to say a couple of words, and he has a slide.
Thanks, Sam. Just a couple of housekeeping bits. Obviously, welcome. Sam may have oversold the pizza slightly. I think you've eaten most of it already. So there's plenty of beer, but probably not much pizza for the break. Toilets and fire escape are both at the back to the right. So just go around there. If there's a fire, you'll see us running. So just follow us. So just a little bit about Just Eat. So we're probably a bit bigger and a bit more complex than people might think. Some interesting stats we have. We really monitor our environment, for example. So we collect over 1.6 million stats on our operational environment every minute, which is a bit of a challenge. We've got over 19 million active customers. I'm not going to read through all of that, but the interesting one that just changed, the bottom one, I can now say I'm a CISO for a FTSE 100 company, because like just yesterday we got promoted to the FTSE 100, so that's pretty cool. But yeah, we're growing pretty fast, and we do over 500 releases a week. So if you want to chat about kind of doing security at a reasonable scale, at reasonable speed, welcome to have a chat with us, because we do solve quite a lot of interesting problems. And hand over to Jeff for some more interesting presentations. Sorry. Okay.
Yeah. I think there's more for me because I have to introduce Jeff, and I have to say quickly a few more things. Right. Major thing which happened at OWASP, we had elections, and these four guys are now our new directors. Right. So I'm pleased to say Sharif, my co-leader, has actually been elected. So he is our new board member. And these guys, obviously, Chenksy is a chief security officer of Twistlock. Owen is the OWASP Dublin chapter lead, and Greg Anderson is the OWASP San Antonio chapter lead. Right. So the reason why Sharif couldn't be here, because he just became a dad of a baby girl. So yeah, he was he managed to do the event last Thursday, but I'm guessing probably fatherly duties took priority tonight. So big news on OWASP projects. In case if you don't know, OWASP Top 10 2017 has just been released on 20th of November, and it's not what everyone expected. You can see all the major changes, right? So we have 3 new items. So that's XXE, XML entity extensions, deserialization attacks, insufficient logging, and monitoring. So these are 3 new items which are in. We have a few items which are merged. So insecure direct object references, or IDOR, how we used to name them, now merged with missing function level access control. And then we now have a new OWASP Top 10 item called broken access control, right? Also, we have a few things which are out, right? So we have unvalidated redirects and forwards are gone, and cross-site request forgery is gone as well. Now, mainly the reason for cross-site request forgery leaving OWASP top 10 is because there are a lot of frameworks these days which take care of CSRF, this vulnerability. So that's why it's kind of slipped. So it's now, I think, number 15 rather than number 10, right? And unvalidated redirects and forwards also slipped because we're not seeing that much of it. But what we're seeing a lot, of course, is XXE attacks, used a lot for DDoS and retrieving files. And of course, everyone heard of the Equifax attack, which was obviously caused by the insecure deserialization, right? So deserialization is now quite hot topic. So yeah, make sure you serialize and deserialize your objects responsibly if you're a developer. Right, another big news on OWASP Zap, our flagship project, our best web application penetration testing tool, which is absolutely completely free, so you don't have to fork out lots of money for Burp or any other tool. You can get the new version, Zap 2.7.0, right? So it's out, been released just 2 days ago, so please go and download it. There are quite a few new features and then enhancements. I can say that I contributed to one of them, so Zap can now listen on multiple IP addresses and ports, just like Burp. So that was done on my request. So please download and use it. Another new project we have is called OWASP Cloud Security. So Fraser Scott from Capital One was the guy who started it. So if he's here, I think he was planning to be here. Yeah, you can ask him questions. Now, threat modeling is very important. This is what the project started on. So if you guys can contribute on threat modeling, cloud security risks, please do join, please contribute. All of us projects are open and you guys can contribute at any time. Right, so we have a new sponsor, HackerOne, and they contributed a free ebook, which is called Web Hacking 101, How to Make Money Hacking Ethically. Right, so I'm not going to show you the URL, but if you go to Google and you type Hack, Learn, Earn, ebook, you'll find it, right? So you can download and read it. Quickly on conferences, Black Hat Europe is coming to London next week, so there will be OWASP booth there. Yeah, that's a very important event, but also it's a commercial conference which is costing a lot of money. So if your company can sponsor a ticket, please do go. Now, free conferences, our conferences. So here, probably you can all, when you arrived, you felt very cold weather and actually was snowing this lunchtime earlier today, right? And while the weather is really bad, this people in California chapters and LA chapter, they're actually having their conference on the beach. So it's happening on Santa Monica State Beach over 4 days, January 28, 29, 30, 31st. So first 2 days are training, last 2 days are conference. So if you want to go to somewhere nice and warm in January and enjoy a whole bunch of people talking about application security, then yes, AppSec California is happening in January, and this is the venue. Very nice place to be in January. Right, we have our own summer event called OWASP Summit. That's happening 4th to 8th of June. So this is all workshops, not presentations at all. So these are people working together on improving OWASP projects. Right, this is all brainstorming, new projects, enhancing existing projects. You can see that we had a very successful event last summer. All people came from all over the world, lots of participants. Yeah, so please, if you want to contribute and work with other like-minded peers, help us shape projects of OWASP. Right, so most important event of the year for people in Europe is AppSec Europe. Now, it's actually happening in Israel. So yeah, there are a lot of questions why Israel is in Europe, but I'm told it's a bit like Eurovision, right? So if Israel's in the Eurovision, they can run Application Security Europe Conference. So if you are a speaker and you want to present at a massive international conference, now this is your chance because the call for papers is open and submission deadline is January the 5th, which is only 5 weeks away. So please submit your proposals. And yeah, if you'd like to speak, you can go to Israel next year. Now, we are always looking for speakers. So if you'd like to present a talk on 3 tracks, which are breakers, defenders, or builders, please email your talk proposals to us, owasplondon@owasp.org. Okay, now again, a reminder that you can ask live Q&A questions using this app, Slido Do. So please take your mobile phones and make sure you are ready for Q&A. Now, it's my great pleasure to introduce Jeff Williams. Now, he's always the most visible person in the room because I think he's taller than everyone else. But obviously, this man is absolute legend because OWASP was actually founded by Jeff many years ago. And 17 years ago, when people were only starting to understand the risks and vulnerabilities around web applications, Jeff was basically at the forefront of all these issues, putting together OWASP Top 10. So Jeff has been a board chair for many, many years after creating the foundation, because he basically converted OWASP from being just a mailing list and a virtual kind of organization into organization we have today with 45,000 volunteers and 200 countries participating. Of course, OWASP Top 10, I'm told there's an urban legend which turns out to be true. So I heard that OWASP Top 10 was created by Jeff when he was in the shower. And I asked Jeff, it turns out to be true. So basically the story is Jeff went to a meeting with a whole bunch of executives of the company, and they were trying to sell application security concept to them, right? So this is like 2001 we're talking about, right? And no one could understand. It's like, oh, there are just way too many risks, and it's like we can't get our head around this, and yeah, we need like top 10. And when Jeff was in the show, I said, okay, we'll give them top 10 and we'll call it OWASP Top 10. So this is how we have OWASP Top 10 these days, right? So many thanks, Jeff, so for a brilliant idea that now obviously everyone in the world is using Top 10. Now, WebGoat, who in the room is using WebGoat? You see, almost everyone, right? So I'm pleased to say that it's Jeff's baby. And obviously enterprise security API is, again, one of the projects that Jeff created. And I think this sign was originally designed by Jeff as well. And I think almost every single project here, Jeff is a contributor. So it gives me a great pleasure, Jeff, to welcome you here in London. So yeah, it's all yours now.
Okay, this working? That sounds good. Thank you, Sam. That was a wonderful introduction. I appreciate that. And you want me to hit share on this?
Yeah, select what you want to share. Share button.
Share not.
Yes, yeah, we can see. Cool.
I don't want to share that. I want to share this. Okay. Let me. Oh, and did you leave your power up here? Oh. So I need some nice British power. So thank you very much, Sam, for the great introduction. Thank you to Just Eat for having us here and having drinks. It's wonderful. And thank you for the pizza. That was easily the best British pizza I have had in a long time. I don't get to England very often. I have 4 kids at home, and so you know, even while I was helping to create OWASP and starting chapters all over the world, I never visited any of them. So this is actually a real pleasure to come out and see you guys, and the turnout is amazing. I want to thank you all for coming out and being part of the OWASP community. It's actually really important that you guys participate and hopefully become contributors to OWASP. We are just barely scratching the surface of application security. I've been doing this for 25 years, and we are in the Stone Age with regard to application security. I'm going to show about 3 slides that are, I think, terrifying about sort of where we are, and then hopefully I'm going to try to present a vision for where we might go and how we might be able to make it better. But look, I've been through, so when I started my career, I was a software developer. I worked on a bunch of different projects, and we used formal modeling for security. We actually mathematically modeled security in large systems. I mean, it was a ton of work. Didn't work, right? It's way too complicated. It didn't scale at all. So then, you know, later on, we started doing things like penetration testing. Had a whole bunch, and that doesn't really scale very well either. We looked at maturity models. I wrote the ISO standard SSE CMM as an idea for advancing security, and it doesn't work. It doesn't scale. It's like too heavyweight. Now we got different maturity models like OpenSAM and things like that. I'm not a huge fan. I think they're kind of backwards looking. We've tried things like threat modeling and security architecture and code review and on, and we're not making any progress. We've really got to think hard about what we do to improve application security, and you guys can take leading roles in what happens with AppSec. Software is amazingly powerful. It's moving forward at an unbelievable rate, and there are huge opportunities. It's like we just discovered the ocean, and we got to go explore all the nooks and crannies. We know very little about how to reliably write secure code. So this talk, I'm going to talk about the 3 ways of security, and this is modeled after the 3 ways of DevOps that Gene Kim, a good friend of mine, talks about in his book, The Phoenix Project. Has anybody read Phoenix Project? Great. This talk's going to be very easy for you guys to latch onto. For the rest of you, go read it. It's really, I think it's an important work, and it's a fun read. So a couple terrifying slides. First off is really, today's security is a disaster. So when I wrote the OWASP Top 10 in 2002, I had this idea. I was like, okay, well, we'll write down the risk. I actually thought it was late, by the way. I've been doing AppSec for a number of years at that point, and I was like kind of writing down, I thought it was too late to have a standard like that. Right? I thought like everybody knows everything about AppSec already. So just give you a perspective, like right now is really still the beginning of AppSec. But I wrote this top, and I thought like, okay, well, I'll write down the top 10 things. There's like 100 things or 200 things, but I'll just write down the top 10, and hopefully, in a few years, we'll knock a few of them off the list. And we'll write another list that's like, keep moving the bar up over time. That's how we'll get better. Awesome. That didn't happen. OWASP Top 10 is still essentially the same as it was in 2002. There's move a few things around and so on, but actually it's funny, like the access control one is now back to the way it was in 2002. So it's shuffling deck chairs a little bit. I'm not actually really very excited about the top 10. That was a throwaway project for me. I thought like, well, it's like kind of a marketing kind of thing. I don't think that's actually the right, it's not the limit of AppSec. It's not actually even really a great way to think about it. What it is a way to get more people involved. So if you run into people that don't know anything about AppSec, it's a great way to say, hey, look, here's these 10 things. Just think about doing these as a starting point. So that's kind of what I think it's useful for. This is a problem. So the average application out there today has about 2 million lines of code. 21% of that is libraries. That's going to be a problem. So 21% of that is libraries. Is custom code, and the other 79% is libraries. What's interesting about that to me is that only 8.5% of the application is actually libraries that are invoked. The vast majority of libraries are never called at all. So we read a lot about library security. Equifax was a bit caused by that problem, and it's got a lot of press right now. But I want you to keep it in perspective. A lot of this talk is about keeping things in perspective. So most of that library code is unused. And look, there's only a couple of vulnerabilities in every app on average that come from insecure libraries. So they're important. Don't forget them. But they may not be ever used, which means you're not vulnerable, and they're only a small percentage of the vulnerability in the application. Now this top piece, the custom code, that's where the vast majority of vulnerabilities live. 26.7 vulnerabilities on average. So this gives you sort of the lay of the land, but what's terrifying about this to me is that is way too many, by like orders of magnitude. Can you imagine if we were flying planes around that had 26.7 serious safety defects? That would be nuts. The airline industry doesn't tolerate that kind of crap. And we need to be better. We can achieve those kinds of numbers in security if we get serious about AppSec, but we're not serious about it. Most companies don't take it very seriously. And so we end up with this situation, and we keep chasing our tail. We keep pointing out, hey, you're vulnerable, better fix it. And they go do that, and then they introduce more, and we're not making progress. So it's been like this for 20 years. And we're not, unless we do something different, it's going to stay like this for another 20 years. And that's going to be really bad because applications are are getting, I think of this as sort of the three C's, the perfect storm. They're getting more critical. So we're doing more important things with them, with money and defense and finances and so on. They're getting more connected, and they're getting more complex. All those three things are bad for security. And so, looking forward, this situation is 26.7 bad now, yeah, but tomorrow it's really bad, and people are going to start getting killed. The second thing is that software is leaving security in the dust. So, when static and dynamic and WAF tools came out in the early 2000s, there's a lot of research going on then. We had simple web applications, and those tools were sufficient. But in the meantime, software has exploded. I knew we were in trouble in like 2007. I saw my first single-page app with a JavaScript fetching from a service on the server side, and I couldn't intercept it with, I think it was WebScarab at the time. Now it would be like Burp or Zap. And I just get all these pop-ups, all these intercepts. Oh, it's like, how am I going to test this? I got to write automation just to test this app. And then since then, it's been just an explosion. APIs are incredibly hard to test with those legacy tools. The move to the cloud has introduced the speed and complexity of apps. But probably the biggest change is, well, there's the explosion of frameworks and libraries and stuff. Now we've got like 200 libraries per app. There's a lot. But probably the biggest change is the move to DevOps. And the speed of software deployment has increased so dramatically that, I spent a long time being a security expert, doing code reviews and pen tests, but I can't fit into a DevOps pipeline that's deploying 6 or 7 times a day. So in that sense, I'm the problem, right? Experts in the development pipeline is the problem. So we've got to figure out how to change ourselves. As security experts, we've got to change from being experts in the critical path to coaches and toolsmiths so that we can get out of the critical path and allow software to flow into production immediately without having to take weeks or months to get secure. And the last thing, and these are just 3 sort of random points to demonstrate the situation that we're in. I could go on these, the problems with the way software security is for a long time, but I don't want to waste my time doing that. But this one I think is actually really important. Software supply chain is totally broken from the ground up. It's not just Equifax and using libraries with known vulnerabilities. It's the fact that those libraries are produced with almost no assurance. Anybody out there in the world can write an open source library and publish it and put it out there for people to use. Companies are betting their future on those libraries. And we don't really have very good assurance in them. But if you think about any other industry with a software supply chain, like the pharmaceutical industry or the automobile industry or Apple, they've got incredibly well-developed QA across the whole supply chain to make sure that they can deliver high-quality products on time. We have nothing. We don't even have a notification mechanism, so if someone discovers a vulnerability in some sub-library of some sub-library, no one gets notified. That's bananas. If you look at Equifax, that vulnerability came out on March 7th. By March 8th, we were observing widespread attacks from a whole range of countries, targeting broad ranges of IP addresses, just random scans. That attack was actually an expression language attack. The deserialization flaw came out later. There's 2 major vulnerabilities in Struts 2 within a span of a few months. But this first expression language attack was really simple. 1 HTTP request with 1 content type header that has an expression in it. That's it. When that request arrives at any application running Struts 2, Struts 2 said, whoa, that's a weird content type header. I'm going to generate an error page. And they take the contents of the content type header and they put it into the error page. And as part of rendering that page, they evaluate the expression, essentially running the code inside the expression. Boom, complete host takeover with 1 HTTP request. You can write a little curl script of 3 lines to spam the internet with that almost immediately. And that's what we saw happening. So essentially, companies had less than 1 day to protect themselves. Anybody think their company was protected against this within a day? Now, the outrage about this vulnerability was crazy. People went bananas, like, how could this happen? Well, every single company I know of has this problem. They cannot respond in less than a few months to something like this. It takes them time to find this vulnerability, it takes them time to replace the library, rewrite their app to meet the new library, retest it, redeploy it, resecure it. That takes time. And so this is a serious challenge for us. I think this needs to be, we need to do what we can do to prepare for this so that we can respond within hours. Next year after that's probably going to be minutes. I think this is really a big challenge for AppSec. Okay, so let me sum up. If you think about diagnosing the problems with AppSec, I want you to imagine your application portfolio. This could be tens or hundreds or thousands of applications, depending on the organization you work in. But when you look at what we're really delivering, we do scans on these applications every once in a while, and you get like this little strobe light visibility into what's going on in one of the applications. And at the end of the year, we've probably only looked at like 10% of our application portfolio. That's pretty typical. Anybody got an organization where they only look at the critical applications and don't really do much with the rest? Liars. So at the end of the day, we're delivering this. Like, we're delivering the assurance that, well, I ran some scan, right? Not very good assurance. We need to be delivering something totally different. Oh, and by the way, we're wasting a huge amount of time to achieve these results. I've seen apps that are being tested for SQL injection that don't have a database. That's probably not going to work. We need to be a lot smarter about what we're testing in the application. So I want you to think about a different result. What security should be delivering? This is the whole application portfolio. We need to be delivering assurance that all the right defenses are in place, that those defenses are effective, like they actually work, they're correct, and that those attacks are, any attacks on those applications are detected and blocked. That, to me, is a pretty reasonable assurance case. Now, here's the point of this talk. If we identify really clearly what we're trying to deliver, we can do it much more efficiently than we're doing it today. We can use the techniques of DevOps to achieve this result much, much faster than we could do any other way. And so that's kind of where I think we need to go as an industry, is focus on what we're trying to deliver and deliver that value really fast. So let's talk about how we get there. Just to introduce DevSecOps, this didn't go over at all before. So this is an American Super Bowl commercial, Puppy Monkey Baby? No? Okay, never mind. In my head, that is really funny. So, no, it's over. The moment's gone. It's gone. It's just, we'll move on. So I'm going to take a second. For those of you who don't do DevOps or haven't really experienced DevOps personally, we're a DevOps organization, so we deliver code 6 or 7 times a day. But not everybody's really experienced it, and you may get the wrong sense of it from reading articles online. People talk about automation, they talk about pushing left, they talk about merging dev and ops somehow magically. I think really, and I'm not going to try to summarize, I'm not going to try to like tell you the Phoenix Project story, because that's the best way to learn about this. But I'll say, when you read that book, look for the 3 ways. It's sort of the core theme throughout the book, but the first way is to focus on establishing workflow. It means you're getting the work. And for security, this would be like those things I just said. The defenses are in place. Delivering that work and getting it flowing through the organization so that it's broken up into little pieces. The work is moving on, through the organization. It's not heading backwards, things like that. The second thing is to create instant feedback. As you're doing that work, you don't get far off the rails, right? You don't introduce a problem here and then 6 months later discover the problem and try to fix it. You're continuously checking to make sure that you don't go far off the rails. And then the last piece is the culture of experimentation and learning. And this is probably one of the most critical things for security, is to create that security culture. And I think the idea of this is how we achieve an organization that can advance its security, right? Not just doing compliance, checkboxing things, but actually thinking hard about how security ought to work and getting to that point. So with that summary, that's kind of a theoretical or like a scholarly kind of thought about DevOps. To me, this is what DevOps looks like in my head. I mean, this is not what it looks like in my head. Never mind. But I like this picture because it kind of shows, small batch sizes moving through an organization, and instead of trying to do like big chunks of work all at once, here we've broken the work up into little tasks that can flow through the organization, and at the end we produce awesome software. It all comes together. But you can imagine like feedback loops here, where if things go off track, they get corrected and reinserted. It's fun to look at, isn't it? These guys are like, we can have, if there's a problem, you can swarm on that problem and fix it. You can optimize your work for downstream consumers. This is like, how do you organize the machines in your factory so that the work really nicely flows from one to the next? A good example of how we fail at this in security is PDF reports. We are not optimizing for downstream consumers of our work. When we hand them a 500-page PDF report, that is almost unusable. So if we think about how the downstream consumers want to consume security, we'll deliver it in far different ways, okay? So just a few examples, but to me, this is like how DevOps is. All right, so the question then is, can DevOps help security? In software, the problem was, poor quality, we're late, slow, it doesn't provide business value. That's what we're living today, and or we were living. And then, DevOps really, I think, is a powerful solution. If you look at the metrics for projects that practice DevOps, they're amazing. Here's just a few of them. 5 times lower change failure rate, things like that. And so the question is, can we do something like that for security? Here, if you think about the problems we have with security, it's exactly the same, right? We're poor quality, we're late, we're slow, we don't provide business value. That sounds kind of familiar. So maybe, just maybe, DevOps is an interesting approach. Now remember, I've been through a lot of, I thought that the SSE CMM was the solution. I thought that formal modeling was like the solution to security. So I could be wrong about this too. So let's just take it one step at a time. But if we think about what we want to try to achieve, wouldn't it be great if we could 10x the portfolio coverage, like actually cover all the apps in your app portfolio? Reduce vulnerabilities by 80% that make it to prod, right? Somehow in our process we want to eliminate those vulnerabilities. And what if we could do it without adding time to market? Those are all really interesting, powerful metrics. If we could achieve that, then we know we've succeeded. So, so how does that work? Okay, that would be great, Jeff. Explain that. So first I got to say a couple things that I think it's not. And I'm pretty sure that DevSecOps is not just taking traditional application security activities, things like static analysis and dynamic scanning and pen testing and WAF, and just shoving them into DevOps. I don't think that's going to work. A couple specific problems. I see a lot of organizations trying to do DevSecOps, and they take a scanner tool and they add it to their CI/CD pipeline, right? So now as they're doing their build, they're invoking the CI/CD tool, the scanning tool, and it runs a scan and it delivers some results, and then they continue. To me, automating the scan button is not really the hard part of this challenge. That's not really helping us. We're going to run a scan. We're going to generate a mountain of false positives, and then a human has to come in and review this, an expert. And so we've eliminated all the benefit from what we tried to automate. Automating is like no experts involved. If it's not no experts, it's not going to scale. And the other thing is I hear a lot of people talking about pushing left. Anybody push left, do security early in the software life? Well, it's not a terrible idea. Security is way cheaper early in the life cycle, right? Like if you can fix it in dev, it costs a lot less. And there's these neat little charts that show how much cheaper things are to fix in development. By the way, that chart is really misleading. it is not a smooth curve. It looks like, oh, look, it's, you know, it's 1x in dev and it's, or in requirements, and it's 10x in dev and it's, you know, 100x in production. That chart actually goes up, you know, like 5 minutes after the developer commits the code, the cost of fixing that vulnerability goes up dramatically, right? So it's like this really bumpy curve, actually, if you get into it. But the idea of pushing left isn't realistic. If you just take these kinds of activities and push them left onto the developer, well, these are not activities that developers can do for the most part. These are expert security activities. We need to do, if we push left, we got to do something different. We can't just have the developers run the scan. I mean, that would be convenient for security people. Yeah, developers, you just scan. That's not going to work. We got to change the work if we want to achieve better results. So, now I'm going to try and interpret the 3 ways for security, right? And so if you think about, and this isn't really DevSecOps. Like really what we're doing is we're applying DevOps concepts to the process of building security. And so I'll just go through the 3 ways, right? The first is establishing security workflow. Like we got to figure out how to get that work flowing, because right now it doesn't really flow very well. Second, we got to figure out how to give instant security feedback. Right now our security feedback comes way too late. And the last is how do we build that security culture? So we're going to dig in. I've got 3 ideas in each of these categories that I'm going to talk about, but these are not the only ideas. These are just you know, a few potential ideas. Hopefully it gets your brain thinking about this, but there's a lot of research and work to do to flesh these concepts out. All right, so let's talk about the first thing, getting security work flowing. We got to pause here for a second. We got to talk about like what is security work. Anybody know? Like what do we deliver? Well, what's the value that security produces? What do we generate? At the end of the day, when you leave work, what do we hand over to the customer? Say again? It's a weird, that's not really very tangible, is it? Like reducing risk, we produce literally negative something. Comfort, also not very tangible, is it? Yeah. Those are concepts for sure. That would be nice if we could deliver those, but how do they manifest themselves? Like, or who do we hand them to? Yeah, how do we communicate that with the people that need it? You know, I might know there's less vulnerabilities, but how do you know? It's a complicated problem what security actually delivers, and it's kind of a symptom of what's really wrong with security. We're not really delivering anything. So let's talk about the work here. Yeah. No. I mean, what are we delivering, or what should we be delivering?
The answer to the question you just asked, would it not be different 10 years ago versus what it is today?
I don't think so.
What would the answer today?
So today, I really don't think we're delivering very much value at all. I mean, you saw my chart. I put up a box full of like.
It's very honest, because invoices and people are paying them.
I understand that. I get it.
I agree with you. I agree with you 100%.
Look, I'm not saying that that the work that we do is not valuable. It's really hard. Some of the smartest people I know are in doing security consulting. But think of it this way. Imagine we were fighting malaria or polio or something. We could have tons of really smart doctors out in the field treating people individually and making zero progress against malaria and polio in general, right? So when I think about security, I'm thinking about the public health version of security. Like, how do we as a nation and a world get better at security and eliminate some of these flaws forever? I want to, wipe polio off the face of the planet.
That's why I asked the question.
Yeah.
What the answer would be 5 years ago, 10 years ago.
No, it's the same.
10 years ago, it's not what it is today. Today we have so many new threat factors with terrorists, with destruction motivation, nation states hacking for changing the direction of other nations. Guess what? These are potentially catastrophic.
Sure.
We didn't have that catastrophic value maybe 10 years ago.
Yeah, well, either way, we weren't producing what we should, right? Like it's essentially the same in my head, it's kind of the same thing. Regardless of the threat, it's, I feel like we should be delivering assurance, and we're not. And so let's spend a second. I'm going to come back to that thought in just a second. But let's talk about exactly what the work is, right? Like the things that we do in security. So there's, I think there's 4 categories of work. The first thing is things that provide business value, like the things the business actually cares about. Typically, this is things like compliance. It's things like, key security controls that are defenses that we actually build and deliver. That's the first category of stuff. And remember, we got to get all of this work flowing, right? So it's useful to just say, hey, here's the categories of work we got to plan for and figure out how to deliver fast. The second category is what I'll call internal security projects. These are things that, we do them all the time, but they never see the light of day. They're like, scans and vulnerability assessments and threat modeling and things like that. Like those are internally consumed things that we got to build and deliver as part of our work. The third thing is operational security work. And this is patches and threat monitoring and event handling and things like this. Application security in operations is pathetic. I don't know any companies that really have good visibility into how they're being attacked, who's attacking them, or what systems they're targeting. Because there aren't good sensors to detect those attacks, we don't know. You can look at WAF output, but it's super noisy and it over-reports tons of things that aren't really attacks. So the value gets demolished. We need to be much better in operations. I spent most of my career working on the dev side. I thought that if we just eliminate the vulnerabilities, we can push those apps to production, and I don't really care what happens in operations. But after 20 years, I'm starting to think maybe we're not going to be able to deliver perfect code every time. So I've opened my heart and my mind to security in operations. We need much better sensors there to detect attacks, to give visibility into those attacks, and to block those attacks so they can't succeed. It is, we are tremendously weak on this side of things. We're only a little bit weak on the other side. So we got to do that. And then the last piece is what I'll call unplanned security work. This work happens all the time. Like Equifax is a good example, but these kind of unplanned things happen all the time. A new requirement comes down, new PCI standard comes out, whatever, new attack, new library, whatever. So just understanding this work is really important. I want you to think about breaking this down and figuring out who's going to do it and how you can actually deliver it. Okay, so now we're into the first way. So that was just like, what is the work? We got to understand that. But let's talk about the first way. How do we get this work flowing? So here's 3 ideas. The first is create a concrete security story that evolves over time. Now the idea here is, if you think about the deliverables that we have in security, things like security requirements and test cases and user stories and threat models and architecture and all those things, they're exactly the same. They're all really different views of the same thing. Like if I chose one topic, like clickjacking, right? I could just write it once and say like, here's what we do about clickjacking, and it covers all of those things. But we create all these different deliverables and they're not in sync. So anybody got a secure coding guideline? Okay, if I helped write that, I apologize, but those documents are not effective. Every developer I talk to is like, yeah, I think we got one. Never read it, not a chance. We're not delivering. We need a security story that brings together all those views consistently. What we want to do is, and so security story to me, it maps the threat model. So what do we care about to our security strategy for that threat, like for each of those threats, and different strategy for different threats. And by the way, there are multiple different strategies you can choose for clickjacking and XXE and other things. Then there's the actual defense that we choose. How are we going to implement it? What library are we going to use? What product are we going to use? And then there's assurance that that thing is right. If we have that line of sight, I can have a pretty confident discussion that I've addressed that. And we'll talk about an example of that in just a second. But this idea of having a security story, it has really good effects on your culture. It enables communication. So if someone asks you, how do we defend against XXE? Oh, well, we do this. I'll tell you in just a second how you do that. It aligns everyone in your organization around this team, and it allows you to evolve. You can go to that document and you can look at it and you can say, well, looks like we got a pretty good story for A, B, and C, but what are we doing about SSL versioning or something? And you can just choose a threat, choose the things that are most important to you. Right now, when we do security, we do everything in security, from the most important stuff down to like the 150th most important thing, like log injection or using system out print line. Anybody seen that from a static analysis tool? It says you're using system out print line, that's not an appropriate logging method. Guess what? No one has ever been breached because of that flaw. Not in the history of the world. So if you're dealing with that before you deal with command injection or something, you are bananas. So look, we got to deal with the most important things first. So this is a very agile way of thinking about things, right? Like if in agile development, you choose an important story to the customer and you deliver that all the way through. Well, we need to do that with security. Let's pick our most important risks and do that all the way through. Strategy, defense, assurance, the whole thing, deliver it, and then move on to the next thing. That's a very agile way of thinking. I think of it as vertical security, like you do the most important risks, as opposed to like inch deep and a mile wide security. So this first thing, capturing your security story, is important. If you want more information about it, you can go to the Rugged Software Project. We've talked a lot there. There's some documents about how to build a security story and what should go in it. The second thing in the first way is enable development to build security. So I want you to imagine breaking down security tasks from, like a big architecture review or a big scan or something. Break that down into little tasks. And then most of that work can be done by your normal processes. If you define it well, developers can do most of this. I'll give you an example in the next slide. But the idea here is we're going to deliver security one little piece at a time. We're going to get that work flowing. We're going to move on to the next one, and we're going to keep it flowing. Every time we do one of these workflows, a sprint, if you will, we're going to add a little bit to our security story, and we're going to continuously enforce it forever from then on. We're raising the bar over time. So then the last piece here, this is an example, right? You want to work on your biggest threats one at a time. So let's talk about XXE. Right? We just added to the OWASP top 10. It stands for XML external entities. And the idea here is if you accept an XML document from some untrusted source, the attacker could include a doc type in that XML document. And when your XML parser reads that XML document, they will process the doc type header. And guess what you can put in the doc type header? System commands? Yes. So it's a really easy way to send a command to an application to have it execute it. You can also include a URL that the XML processor will then try and get on the back end. So you can actually force a web application to reach out to another internal server inside the intranet. That's called SSRF. So it's like XXE to SSRF kind of flaw. So what do we do about XXE? Well, it's really not that complicated if you think it through. So let's decide that's a risk we're gonna deal with, right? We prioritize the risk, we threat model a little bit with, okay, XXE is our next thing. Well, then you choose a defense strategy. There's a couple things you could do. You could decide, well, we're not gonna accept untrusted XML. Okay, it might limit your APIs. Maybe you decide it's all JSON for us from now on. Okay, that's good. Or maybe you decide you're not gonna allow doc type processing. So most XML parsers, you can just disable doc type processing, and then you're safe. It's easy, right? Okay, so we choose a defense strategy. Then we go implement it. Maybe we have a standard library that we use for XML parsing. We could stand up a service that we use for that. Then we build some testing. We want to make sure that we're only doing our strategy everywhere. We'll talk a little more about this, but this is a positive way of validating that everywhere we handle XML, we're doing it right. And you may put attack detection in place. Like just because you're not vulnerable doesn't mean you're going to detect people who are attacking you with XXE. So you want that sensor in place because you want to know who's attacking you. And then the last thing is, you can go to monitoring. When you go into production, now we're monitoring, we're feeding, and if we ever see an XXE attack come in, we can respond. We can block their IP address, we can disable their account, we know something's going wrong, we can take a response. So to me, this is a great story. And if you implement this, then you've raised the bar for security from now on. And it's not difficult. I don't think we need security experts for very much of this. To implement this, this is the kind of thing developers can implement every day. Any questions on that?
Questions afterwards.
All right, that's fine. That's probably better to do it that way. All right. So definitely think of some really hard questions because I really like that part of it. So I'll speed through the rest of this so we can get to that. So let's move to the second security way, okay? That was all about getting the work flowing, just breaking it up into chunks and getting it flowing. Let's talk about what we do to prevent going off the rails. So we're going to enable instant security feedback. So a couple things here. First, if you want to secure something, you got to know what's inside that something. Like what's inside the circle of things we're going to secure. Turns out most organizations don't know where all their apps are, and they don't know what's inside, what software is actually running as part of those apps. They don't know what libraries they're using across the enterprise. That's all actually really simple information to gather. So what we've done is we try to implement something called self-inventory. And the idea here is you can add some code to each of these applications that will just report, what am I? So I'm this app, I'm running on this server, and here's the set of libraries and versions that I'm using. You report that all to a central server. So then, now you know, like here's all my apps, and it's constantly up to date. So you don't have this kind of like, I don't know what code I'm running where problem. When Struts 2 comes out, you just go ask this thing, and within 1 second it tells you, oh, well, here's the 5 apps that use Struts 2, and here's exactly what servers they're running on in dev, test, and prod. Say again? I don't think so, but let's take that offline. I'm happy to yes, does that create a vulnerability? It's really just one-way information out. And this isn't public, by the way. You don't have to publish this. This is just internal to your organization. So anyway, this is like a simple way to solve a problem that plagues most organizations. This is not hard. We just got to decide to do it. Second thing is, and I've talked a little bit about this, but we really need better threat intelligence. You need to know who's attacking you, what techniques they're using, where they're coming from, and what they're targeting. That information will allow you to prioritize your AppSec program. Right now, folks are just fixing vulnerabilities because they think they're important. But knowing what's actually being attacked is critical to that decision, and we're just blind there. So I strongly encourage you to put the sensors in place that will allow you to detect attacks in production so you know what's going on. Most organizations have a serious blind spot here. SIMs don't have information about whether applications are being attacked. They just take logs. Frankly, the only way we know what's going on inside applications is through log files, which are terrible. Log files have almost no security information in them. It's very difficult to tell whether you're being attacked by looking at logs. So this is actually a really important capability. This is, by the way, an example of the Equifax attack that happened just a few days after the vulnerability was released, but this is a real one from China. And you can see the expression there that it was just part of the content type header. It's just that simple. And then the last thing in this category is to create what I call an application security control plane. Now this is a little bit, we have network security control planes. Like you can monitor all your devices and get security information about all your devices. We have nothing at the AppSec layer, right? When you put an application out in the world, it's just out in the wind. You don't know what's going on with it from a security perspective. So what I'm recommending is enhance those sensors so that now, no matter where the application runs, it's reporting. Sorry about that. I really want to get close to the screen. I know. We want to get telemetry from these applications as they're running about where vulnerabilities are, where attacks are happening. We should gather that information and feed it into some kind of central console dashboard where we know here's where the attacks are going, here's where we're vulnerable, and keep this happening in real time. That's half the problem, is just gathering that information. The other half of the problem is, what do we do with it once we gather it? Do we just put it in a PDF report and not do anything? I have a CISO friend. I said, what do you do with your vulnerability reports when you get them? And he said, come here. And he opened the door of his office, and behind it is a bookshelf filled top to bottom with consulting reports. It must have been millions of dollars worth of work. And I was like, are those all fixed? He goes, I don't know. We gotta do better than that, right? So the idea here is, let's take this security information and feed it to the people that need it through the tools they're already using. And let's do it instantly, right? Instant feedback on security problems. So imagine a developer is typing along, they introduce a SQL injection problem, we detect it locally, we note it in our dashboard, but then we deliver it to them according to some set of criteria based on what he wants to, how he wants to be notified. Some organizations, it might be like chat ops. We might want that vulnerability through Slack or HipChat. Someone else might want it through Jira, or somebody else might want it right in the IDE. We need to deliver, we need to come to them and deliver vulnerability and attack information through the tools they're already using. We need to be in tools like Jenkins and Bamboo so we can fail builds instantly when there's a problem in code that gets delivered. And we need to deliver attack information directly to the SOC so that we can open up a new world of visibility to the SOC guys so that they can respond to application attacks. This is how we get this sort of virtuous cycle. We get information together, we get it to the people that need it, they can make improvements, redeploy, and we can quickly solve security problems without having to wait 6 months or a year. We'll talk a little bit more about that in just a second. All right, so that brings us to the third security way, and probably the hardest of the ways, which is how do you build that security culture? I've worked with a lot of companies over the years, and some of them have really good security culture. I'll say it's probably the minority of them, but other ones really don't. They're antagonistic. They fight security at every step. But what's weird is they're doing all the same things. Like they're both types of companies are doing pen tests, they're doing code reviews, they're doing architecture review, they're doing threat modeling, they run tools. They're on paper, they look equivalent. And against the BSIN, they look equivalent, or OpenSAM. But they're really completely different in terms of how they think about security and how successful they are about security. So I want you to really think about, this culture question is tricky. A couple ideas on what you can do to improve security culture. So the first thing is, I would love it if organizations would migrate from a negative way of thinking about security to positive security. Let me tell you what I mean. So most tools and most pen testing basically looks for a set of negative behaviors in applications, like SQL injection. That's a pattern of execution in an app that you shouldn't ever see. Well, there's a million different ways of writing bad patterns of execution, right? But if you decide as a company, like, we are only going to use parameterized queries, okay, winner. That's a positive way of thinking about security. And guess what you need to test is one thing. It's way easier to test that one thing than it is to test all the possible ways of screwing up. So, right now we're trapped in this tight orbit around planet negative. We've got, negative policies, we've got negative testing, and we're just trapped in this patch and fix cycle.
With your permission, I'll tell you why. Because I think you're absolutely hitting the point on the nail. The challenge that I find is that if the top decision maker is not technical, who needs to see the value of why they need to change their mindset, that change of mindset is going to come from the technical expert. Technical experts are not going to speak, with respect, the business language. Neither one of them can communicate. They may be both speaking English, perhaps, but they're not talking to each other.
Yeah.
And they're unlikely to talk to each other because one cannot make the business case for the change of mindset. The other one doesn't understand the technical challenge of switching from a negative to a proactive.
Well, I'll tell you what.
Would you not agree with that?
I think that's most of the way. I think there may be some other reasons as well, but I think that's. Sorry? Oh, what do you want me to do?
So, if anyone wants to ask a question, I'll bring one.
Oh, yeah. Sorry, I can repeat the question if you want. I mean, basically, the question was. Maybe I can. I don't know. The question was basically like, does this phenomenon, the fact that we focus mostly on negative testing, result from miscommunication between security folks and business leaders? And I think that's a big part of it. But what I will say is that that's on us as security folks. We've got to come, I'm thinking of that scene in Hitch where Will Smith kisses Tom we got to come like 99% of the way to the business leaders. We have to learn how to talk to a way that they can understand. And they're going to keep going. Like, they're going to keep building code. They're going to keep deploying it. They're going to keep running the business. It's our job to figure out how to convince them to do something better. This is a simple way to massively reduce the scope of what we do. And if you remember that slide at the beginning, it's not like we're going to instantly get twice as many security folks. If we did, the industry average skill level would drop by half anyway. So it's not going to work to just explode the cybersecurity workforce. We need to do something to work smarter, not harder. And this is a really key way to do that. I've worked with organizations that have done this, and they have systematically eliminated the OWASP top 10. They never have SQL injection, never. They've almost eliminated cross-site scripting. They've got standard defenses for CSRF, and well, it's not even a top 10 anymore. But they are actively working on this approach to eliminate flaws, and it works. Different kind of culture. So the next thing is, I want to focus on how do you accelerate the evolution of your security story. Remember the beginning, I said you got to have a story. Well, your story could be like one control, right? It could be we're going to use prepared statements. That actually would be a better security story than a lot of companies are operating right now. Like the whole story, that would be better if they just eliminated SQL injection. But thinking about how do you evolve that story over time, if your feedback cycle is 1 year, you do an annual pen test, you will never evolve your story, right? You'll just, at the end of the year, you'll start over and you'll do another pen test. It'll start from square zero and you won't build anything. But if you continuously do cycles on small pieces of the problem, well, let's add SQL injection, and then maybe later we'll add XSS, and then we'll move on to authentication and access control, and encryption and logging and so on. You can evolve this story over time. Some of the enhancements are going to be like countering new risks. Some of the enhancements should be like, let's just make it simpler. Complexity is the enemy of security, so you constantly want to think about simplifying your security story. The key to advancing in security is how fast can you iterate this, and it's up to you. You can go as fast or as slow as you want, but if you go too slow, you're just going to be overtaken by software every year. So you got to move pretty fast just to keep up. But this is a way that security folks can communicate with development teams. They can say, hey, you know what? Our next thing we got to do is this. Let's everybody heads down. We're going to focus on this next thing and get it done. It's a different kind of culture, though, right? It doesn't sound like the culture in most organizations. And then the last thing is I'm going to talk about promoting security in sunshine. So in the United States, our government, we have this idea that we should govern in sunshine. There's actually laws about this. Now, whether we practice those things fully these days is probably questionable. But the idea is sound, that we should do security in sunshine, I think is really important. And let me talk about this for a second. I'm going to talk about this cycle. People inherently trust software, which leads to blaming behavior, which causes folks to hide security, which then actually feeds back into this blind trust because you don't have the information that you need. Let me make this a little more visual. People trust software with no reason to trust it. Anybody here bank online? Anybody have any reason to trust the software that they use to manage their money? Do you know how it was tested? Do you know who wrote it? Do you know if they were trained? Do you know what components they use? Do you know how often it's deployed? Do you know what they do to respond to vulnerabilities? Do you know anything? No. You blindly trust it because your bank said, it's awesome. That's crazy, right? We blindly trust software. In fact, anybody ever installed a piece of software that they just download off the internet on their computer? Liars. Some of you, I know everyone's done that. I hear this from people all the time, and they say something like, well, yeah, I was a little worried about it, but I installed it and it didn't do anything, so I guess it's fine. Holy shit. Like, it couldn't possibly be doing something in the background, could it? Or like, yeah, I mean, it's crazy how people trust software, and it's totally blind trust. So that leads to blame. And we've got a serious culture of blame in application security, right? Security folks trumpet, like, I found a vulnerability and developers don't know how to build code. And like, it can, in some organizations, it can get really hostile. Anybody work in an organization where there's hostility between development and security? Oh, thank you. That's some honesty. Thank you. I appreciate that. It's actually a real challenge. And this blame, it ends up focusing on the people that are not responsible. Like often developers get blamed for security vulnerabilities, and it's not their fault. Developers have a full-time job, and it's super hard. They've got to keep up with an unbelievable amount of new things every day. And just because they saw some jerk train them for 3 days, a year ago, doesn't mean that they know security. So it's really not fair to hold them accountable. The problem is really the game. The game is not set up to help them succeed. If we do our job and we're delivering them the information they need in the tools they're already using, we can help them be successful, but we shouldn't be blaming them for getting it wrong. If the blame belongs anywhere, it's right on security experts for making this too hard. And then the last thing is that blame leads to hiding. And I'll just go out and say that not every organization has been fully upfront about every breach, Uber. Right? You get breached, and not everybody's going public right away. We're in a weird era of disclosures about sexual misconduct in the United States and maybe elsewhere. And I feel like the same thing is like at a tipping point for security folks. Like if you get breached, you better disclose. But this problem of hiding security, even inside the organization, I see this everywhere, where vulnerability information isn't shared among developers, among teams. It's hidden, right? Anybody got a rule that says like you can't put a vulnerability in email? Like you have this risk register that's got massive access controls around it so nobody can see what's in there. That's actually really problematic. And I'm pushing the envelope here a little bit, I know, but I encourage you, make that stuff visible inside your organization. Celebrate every vulnerability. Allow yourself to get that information to the people that need it so they can fix it right away. And don't put it in some risk register that's where it's going to fester for 2 years with nobody fixing it. Get it out there, get it fixed. Vulnerabilities and attacks are opportunities to make ourselves stronger. In the Vin Diesel, like it takes 500 fights to get tough. Like that's how kind of the tough we need to get. So we should celebrate attacks. And some of the HackerOne and Bug Bounty kind of programs, I think those are actually really helping that culture go on. You celebrate attacks, use them. So this is sort of an important part of getting a good security culture in place. All right, so that's the 3 ways of security. Hopefully it challenged you to think about this a little bit differently. I want you to go back and really think about how do you get security work flowing in your organization so that you're delivering something real, not just abstract concepts like negative risk or whatever. Really deliver something like a document or proof or a security story that you can articulate to people. Maybe it's a dashboard or a website. Make sure you get that feedback flowing so you don't go far off the rails. And then the last thing is work on that culture. And it's hard from one person's perspective, but that's where it starts. We're it. The folks in this room, in this organization, that is it for application security. There ain't nobody else coming to help. We've got to make this change happen together. So a couple of closing thoughts here. I think a lot of folks kind of think about how do we make software secure and how do we build software securely. I actually want to turn that question around and say, how do we make software security something that you build? When you make it concrete, it becomes something that this machine can deliver. And then you can work on flow and feedback and culture and so on. So I'll stop there and open it up for questions. I love any kind of questions on any topic related to anything, really.
Okay. First of all, let's thank Jeff for his amazing talk. Right, guys. So I know there are lots of questions that I received online. So because we have Bristol online, I think I'm going to give priority to Bristol folk to ask questions first. Right. So for this, Jeff, we need to start streaming. Can you stop sharing your screen?
Oh, yeah.
Testing from Bristol. Can you guys hear us?
Yeah.
Okay, I'm hoping we have questions for you. Thank you very much, Jeff. That was really cool.
Update installed. Thank you, Mac. Okay, so I did
Zoom.
Okay, so we have some questions from Bristol.
So I just need to turn off.
Yeah, turn off the sharing.
Back to meeting. No.
I'll
Share
pass
screen.
it.
It's like disabled. Oh, stop share. There we go.
sharing.
Sorry.
Yeah, excellent.
That's
Okay.
like my first time. Thanks. I'll get out of the way. I'm gonna
Okay.
step
No.
down.
Stay. If you, because people can see you. Yeah, the camera is just there. Right. Okay. Bristol guys, please ask your questions.
Hi, Jeff. How can an organization start a threat intelligence program?
Yeah. So there's really two major sources of threat intelligence. One is internal, by watching who's attacking you and what techniques they're attacking you from. And then there's external sources of threat intelligence. And there's in that there's kind of two categories. There's like attack information, which you may be able to get from like FSI SAC or Solterra, one of those kind of sources. That's really not going to cover application security. So I would recommend OWASP as the other kind of information that you might get about new threats that are out there. Maybe go to conferences like Black Hat or DEF CON and follow folks that do that kind of thing on Twitter. Those are the kind of external feeds that I rely on. And I wish there was a better story there, but frankly, we don't know very much about what's going on in the application security world from a threat perspective. I'll tell you this, last month, we at Contrast, we observed a sharp uptick in padding Oracle attacks. I don't really know what's driving it, but if you all didn't see that too, then you're not measuring it, right? And my guess is that we're the only ones in the world that saw it, because most people don't have the kind of sensors that we have. So, I feel like we need to do a lot better job about figuring out what's really going on. And we're just at the beginning of this, literally just scratching the surface of this problem. Great question, thank you.
Bristol, any more questions for me, please?
The question, 1 second.
Hello. So I work in the operations space. So I guess my question's really around monitoring and observability of this stuff. So I think we've got some good tools in the operations space to see what we see on the platform in terms of is the application performing well. You mentioned there's a problem in the security space there. Is that a failing in tools or how we build the application, or what's the reason for that?
Well, it could be tools. I think it's probably a tool problem. You could use things like App Sensor to try to build attack detection into your application, but that doesn't scale very well, right? Like, are we likely in the next 5 years to get most applications to have attack detection built in? Probably not, right? Like 90% of the applications are legacy applications that are out there. So like, how are we going to add it to them? So we really probably need an automated solution to detecting attacks at the application layer. So yeah, we need better tools. I'm trying to help there.
Okay, I have a question as well from Bristol. So I'm an application developer at Just Eat. I'm not I guess I wouldn't call myself a security expert. I care, but I don't do it day to day. Should I have a broad understanding of security within the domain of code that I work in within Just Eat? So we have a really big tech estate. Should I care about the small part of the architecture that I work on and have a broad understanding of security in that space? Or should I care about a few important parts of security across the whole estate? Because doing both is kind of impossible.
Yeah, that's a really interesting question. I mean, I think a lot depends on how you decide to structure security internally and sort of how your teams are set up. But I will say this, I would focus on the things that matter most, right? Like, don't worry about system out print line, worry about SQL injection and command injection and access control problems and things like that. So, worry about getting visibility for the things that really matter before you worry about things that, like clickjacking is a good example. Like, it's not a huge deal. It's way down the list for me. So, think about what it really means for your enterprise for each of these kinds of threats. And then, actually, so from an operations perspective, I don't think that, doing operations on application security kinds of attacks is really very different from doing the kinds of things you do for network attacks. If we have the right sensors, you'll detect an attack, it'll report into the SIM, it'll show up on your maps and dashboards and cause whatever PagerDuty and VictorOps alerts to go out, and you'll get an alert and you're gonna have to deal with it. And probably that means like, oh, well, I don't know what this is. Let's talk to the development team and say like, is this a real problem? And help, bring them in to help you in triaging what the actual, damage done is. But not a tremendously different workflow, I guess is what I'm getting at.
Hi, I got a question.
Yep.
Sorry, I agree with what you're saying that the developers aren't great at the security thing. We see that a lot. They get a bit of training. They do things great for a little while and then everything sort of falls apart. But how do you sort of address the creating this culture of security and increasing the appetite sort of in the senior management levels when they've got the culture of it will never happen? Yeah, I understand it, but it's not really going to happen, is it?
Yeah.
And then you need to build that into the whole workflows that you're talking about and create that. How do you break that kind of cycle?
Yeah. So on the first part of your question, like I've trained thousands of developers, and almost across the board, they are passionate about security. They're interested. They want to do it right. They try to learn it. So again, I'm not about blaming developers at all.
I used to be one. So.
Okay, good. So
I've been there.
But on the side of convincing management to invest in this, there's a number of strategies. The one that I have found most successful is to gather real data about vulnerabilities and attacks. And you don't have to do it across the entire portfolio, but pick a subset of applications that you can manage. It might be a small number if that's what you can do. It might be a big number, but gather real data and capture it and then extrapolate it. Say, look, we looked at 5 apps and here's what we found. We've got a ton of vulnerabilities. Here's how they break down. And we're actually being attacked a lot. And here's some numbers around that from different countries. And then help explain to them the significance of that. Like, what does that mean? And then extrapolate it across the whole portfolio and say, look, that was 5, but we've got 500 apps out there. So our attack surface is huge. And give them the data that will allow them to justify the investment in improving security. I actually think, doing security smart, some of the ways that I've talked about, are not necessarily much more expensive than doing security the kind of inefficient way that we've been doing security. So there's a lot of opportunities for cost savings here as well. And really, let me follow up on that for just a second, right? So if you do security the traditional way, sort of find vulnerabilities well after they were introduced and then scan for them or something and then try to go back and fix them, they're very expensive to fix. The cost of finding a vulnerability is like $1,000, but the cost to fix it is like $4,000. So even if finding all the vulnerabilities was free, like even if I could hand you all the vulnerabilities in a big database today, the cost of fixing it is where all the cost is. So if you can go to the executive and say, hey, look, if we do this and push vulnerability discovery way left into the developer's environment so they can fix it as part of their normal workflow, we can eliminate most of the cost of security. And so, there's a lot more efficient ways of doing things. Thank you.
Thank you.
Okay, guys, because we're running out of time, what we're going to do now, all the audience in London, can you please ask your questions during the break that we're going to have? However, I hope you were using the app. There are a lot of questions asked using the app. So I'm going to show the questions on the screen, and it's up to Jeff to pick them and ask them about 15 to 20 questions. Okay, so Jeff, if you turn and look at the screen, you will see the questions now.
Yeah. I have no idea what comes after DevOps and DevSecOps. Probably something faster. Good question about AI and machine learning. I am not a fan. So let me tell you why. So look, to do machine learning, you got to have a big data set, right? And to have that big data set, you got to pretty well understand the problem, right? Like you'd have to have like a zillion examples of SQL injection or something like that, right? Then you could train a neural network to kind of find it. But if you really understand the problem, you should actually fix the problem. Like, you know how to do it. You don't need a neural net to identify problems that you know about. So that leaves the problems that we don't know about, right? Like the unknown things. And the problem there is we don't have a data set. How do you have a data set of shit you don't know? And so we end up with this model where AI doesn't really help us on either side of the equation. So that's sort of where I am on this. There are there are uses, but they're narrow to me. I think there's a lot of blocking and tackling that we need to do before we get to stuff that AI can help with. Let's see. If only 8.5% of vulnerabilities are in libraries, do you suggest not to use them? No, absolutely not. I think you should use libraries. You should just remember that when you adopt a library, you're adopting a responsibility to keep it up to date and to have a mechanism in place to respond if there's a new vulnerability that comes out. Why has the top 10 not changed in all these years? I don't know. I mean, it's hard to do some of this. Like I think DevOps actually is an interesting opportunity for us to make real progress against this. But like trying to do it with experts, we can't get in front of the problem. It's just we haven't had the scale. But DevOps provides the automated infrastructure that we can add security to and make much better progress scaling this up. We could have never established that infrastructure by ourselves as security. So we can stand on the shoulders of giants a little bit. Let's see. Even for one vulnerability, the 3 ways is a lot of work involving the business, test, and ops, all different teams. How can security bring all those things together? Well, yes, that's a good question. It's not necessarily easy. This is going to take time to adjust how you do security. But I would do it for one, and try it, and it's essentially the way that people start with DevOps. They start building one sprint, one flow, and realizing the value, and then building on top of that. But it's not easy. Particularly, this question assumes an organization that's not very far along in their DevOps transformation. If they are, then those would be all kind of, they already would have brought those teams together, and you can take advantage of that. So, maybe the best way is to start DevOps. Let's see, let's go down to the bottom one here. It says, do you see RASP more as a detection facility or protection for flaws that are shipped to prod? And really, it's both. I mean, if you can detect an attack, you should probably be able to block it, right? So those two capabilities are very tightly linked together. The trick is you have to be sure. You have to be really sure that it's a real attack. If you block stuff that's not real attacks, you break apps. If you break apps, you're on the street. So the idea behind RASP is moving from outside the application where a WAF runs, where you have limited information to make a decision about whether something's an attack. It's almost impossible to say for certain whether something's an attack. If you just look at the HTTP request, move it inside the app where you have all the context, and then you can make an intelligent decision about whether something is actually an attack and decide to block it only if you're sure it's real. I think of RASP like ASLR, right? It's a defense that's built into the application that makes vulnerabilities harder to exploit. So for buffer overflows, we do address-based randomization, and we can eliminate the ability to exploit those vulnerabilities. The same thing with RASP. We can build into the application the ability to identify attacks and eliminate the ability for them to exploit vulnerabilities. But the visibility is really important too. I mean, so you got to know. Let's see. Was one of your key takeaways that 80% of known vulnerabilities could be trivially eliminated through better supply chain governance? I don't think that's right. I hope I didn't say that. I don't remember saying that, so maybe I'll take that one offline. And if you want to follow up on any of these questions, you can hit me on Twitter or send me an email or whatever you want to do it.
Guys, can I just say the questions will stay on the board, so during the break, please carry on asking questions. So at least it will provide visibility to your chat.
Let's see. So I think that's probably good. I mean, these are questions from folks in the room too. So isn't the problem with IAST and RASP that they're tied to a small number of languages, frameworks, and runtimes? Developers change quicker than they can keep up. That's a good question, and it is a challenge for technologies like IAST and RASP to keep up. But I don't think there's really any alternative. Currently, contrast, we support a pretty broad range of languages. We do all the languages that run on the JVM, like Java and others. .NET, Node.js, Ruby, and Python, which covers, if you think of sort of the pie chart of what languages get used to build apps, particularly apps that people care about, that's a big chunk of it. But I think it's, so let me back up. I totally believe that in the future, every application is instrumented for security. In the real world, we instrument things that are complicated, right? We instrument cars and airplanes and nuclear power plants and factories. We instrument factories like crazy. Heat sensors, vibration, light, temperature, everything. And if anything goes wrong in a factory, we know instantly. Now, software is probably the most complicated thing that man has ever built, and we have completely shit instrumentation. Like, all we've got is logs. We know barely anything about what's going on inside an application if something goes wrong. That has to change. And so I believe in the matter of a few years that most applications will be instrumented for security and other things. And going long term, I think that includes all kinds of instrumentation. You're going to have instrumentation in blenders and dishwashers and airplanes and satellites and everything, because it's crazy to run something super complicated without instrumentation. It's just nuts. So that has to change. And sort of IS and RASP are on the forefront of pushing that envelope.
Okay. I think we have to stop at this point. So thank you very much, Jeff. Let's thank Jeff one more time. Yeah, that was a good one. Okay.
Thank you all.
We're going to break for 5 minutes, right? Comfort break.
Thank you from Bristol as well.
Yeah, and in 5 minutes, David will present his talk on myths about cookie security. Thanks. Oops. Please carry on asking questions. They will be on the video wall.
1, 2. Yeah.
Okay, everyone, can you please start taking your seats because we're quite short of time, and we have David ready to present in a minute. Half an hour. Half an hour, but Q&A will be short.
Yeah.
I'm not from here, so oh, it is. Where is it?
Make sure it was the same thing then.
Okay.
Can you please take your seats, everyone? We're short of time. We only have 25 minutes left for David's talk, unfortunately. And I think we're going to cut Q&A short, so please carry on using Slido facility to ask questions. Yeah. Okay, everyone. Oops. No, I'm too close to the speakers. Right, I would like to introduce David Johnson, who is the Associate Principal Consultant at Synopsys. David has presented at OWASP a couple of times already, and he has presented at AppSec USA, Information Security Europe, and quite a few other conferences. And today he's going to talk to us about cookie security. So welcome, David.
Thank you. Okay, I hope you all can hear me, and without too much feedback, I'll try to stay away from the screen a bit. So this talk we'll try to run through quite quick. It's actually about a 45-minute talk that I did at AppSec in the US. So I'm going to skip one of the demos, and I'm going to go through a bit quicker some of the slides. So if there's anything you find of interest, I would recommend you to Google AppSec USA, and you will find a talk there, and you can see the demos you will miss today. Okay, just very quickly about myself. My name is David, as mentioned, and I work for Synopsys, based here in London since about 3.5 years, nearly 4 now. And what I've been doing for the last about 10 years is work as a security consultant with delivering trainings, reviewing applications, helping developers basically to write and produce and deploy more secure code. And I faced a lot of the challenges that Jeff spoke about earlier today, so I can relate to a lot of that. What we're going to talk about today here quickly is cookie security. And you may wonder why I talk about cookie security. Isn't that it's like, okay, we all know about cookies. We have them for a long time. And we know how they work, right? So when we look at this a bit deeper, it's actually that cookie security is somewhat broken. It's not really always what we think it is. And we have a lot of security attributes and things like that, and we add terrorist cookies to make them secure. But what I've found is that it's not always that they work the way we would expect them to work. And they may not always secure up our cookies to the degree we would expect. And sometimes I see developers and even security experts making some false assumptions about these and how they work. And that's what I'm going to try to explain a bit about today, and just to make sure so you have the right understanding of cookies and where you might be having some weaknesses if you got some of these things wrong. So we're going to start off just with some basics regarding cookies, and then we're going to talk about some of these attributes that I mentioned, 4 of them, and then we're going to briefly talk about some of the newer and more modern protections that are actually being built into some of the browsers today. And also there's a new proposal for updating the cookie specification, which will add a few of these. So we're going to cover that. So let's start with the basics. So cookies that we use are actually based on a quite old recipe, you could say. Back in '94, it was an engineer at Netscape that created this draft for cookies. And the use case they had was to a client that kind of like created an e-commerce site, I guess probably one of the first ones out there. And they needed to store state about the users, like the shopping cart and things what they were looking at and wanted to buy. And they were afraid that it's going to cost them quite a lot on the server side to keep all this information, and didn't want to store all this state information about end users. But as we know, the HTTP protocol is kind of stateless, so we need another way to actually maintain this. So that's how they came up with cookies. And just to let you know, this draft that came out, it said something like, yeah, use with caution or similar, because it was quite short. It was just about 4 pages, not very detailed. Had a high-level overview of how it was going to work, but it left some things unanswered, and people anyway started to implement this. So Netscape were the first ones, and then Internet Explorer came along and did the same. A few years later, in '97, they tried to standardize, okay, now people are actually using these cookies and how it should actually be used. So let's create a formal standard for this. So RFC 2109 came out, and no one really cared. No one really implemented it. And people kept on going with the old Netscape draft. In that way, because everyone was already using that and they were so used to it. And for example, at this time in the new specification, they were trying to actually do some good things. They were trying to push more for security and for end-user privacy. For example, there was a new field, I think was called comment, where the server was supposed to tell the end user why they were setting a cookie, what was the purpose of that, so that the user could take an informed action of if they would accept that or not, or proceed using this website or disagree with that. So a little bit similar to if you're in the EU now, you know the rules. Many websites, the first time you visit them, they have to tell you that they're using cookies and why they're doing that. And you have to give your consent, so to say, by continuing using the site. And if you don't accept, you simply can't use it in many cases. So that was not really big of a hit. So in 2000, they did a new attempt. So RFC 2965 came out. Again, they were trying to make some changes and improve things. Funnily enough, they were actually creating a new header, set cookie 2, and a cookie 2 header to advertise the browser capabilities to support this. But hands up here, how many of you have seen cookie 2's set cookie 2 header or a cookie 2 request header? I don't see a single hand. Oh, there are actually 2 at the back. Yeah, been around for a while then. So it's very, very uncommon. I mean, I've tested many, many applications, and I can't remember ever seeing them being used in practice. And again, it appeared that this was something that most people and developers as well as browsers simply ignored, and they were continuing using the old standard. So again, not much happened until 2002 in terms of cookies. About this time, because of Jeff and other pioneers within application security, people suddenly became aware of that, oh, we actually have an issue here with security issues, and especially cross-site scripting was a big thing then. Unfortunately, still a big thing today. One of the things back then that people tried to do was to use cross-site scripting to steal a session cookie and send it off to the attacker side, so the attacker could then use that to impersonate the victim and take over their session. So what Microsoft did was they came up with an attribute called HTTP only, which basically told the browser that cookies with this attribute should not be sent, should not be accessible to client-side JavaScript, for example. They should only be accessible over HTTP API. In other words, they should be sent with request to the server from the browser, but not be accessible client-side. It took a while, but then other browsers adopted this as well, and they started to implement this feature, and it's been in all the major browsers for quite some time now. So we're all familiar with this. But we still didn't have any formal specification for what should actually cookies look like and what should it be. And one of the reasons why there wasn't work being done to do this was because this HTTP only attribute was implemented a bit differently at times, and there was no consensus regarding it really. And there were a couple of guys related to OWASP, Jim Manico, for example, some of you might have heard about him, and Bill, they were approaching the standardization organization and said, hey, can we write a standard for HTTP only for these cookies? And they came back and said, like, yeah, I wouldn't really bother with that because I don't even have a standard for cookie to begin with. So it's kind of pointless doing it for just HTTP only. So what they then did was to initiate a work where they actually started to try to document and create a standard for cookies. And that's the one we're using today, RFC 6265. What's interesting, though, is that this is actually not a standard saying that this is how you should implement cookies, and that's how everybody did them. It's rather the opposite. They were rather specifying how do people actually implement cookies in the normal process that we use most of the time today. So we're trying to document something that was already out there and specified, rather than trying to write specification that others then would adopt and use. And that's the way it's been, and it was based mainly, again, on the cookies from '94 in the Netscape draft. This year, there's work going on to actually update this specification. It's not a major change, though. It's not trying to do something like RFC 2109 or 2965 to change completely how cookies work, but rather they're adding some new security features to it, primarily something called same site and strict secure cookies and cookie prefixes. And we're going to go over them quickly. So just to everyone be on the same page, what are cookies? Well, they're pieces of information basically that are stored on the client side by the browser. And they're typically set in an HTTP response by the server. Can of course also be set by JavaScript on the client side. And once the client has these cookies, they will include them in request back to the server when you try to get a page on a host where a cookie was set. And these cookies, they also contain a couple of different attributes that then influence how they are handled by the client and when they are submitted to a server. So we're going to talk a bit about some of these attributes and how they relate to security, and some common myths or misconceptions, you could say, that I sometimes come across when I speak with developers and other security professionals. So the first and probably most important one that we all should hopefully know about is the secure attribute, right? So if you've ever come across a pen test report or any security training on web security, I'm bet for sure that someone has mentioned a secure attribute and pointed out you have to mark your cookies with a secure attribute. It's very, very important. And the story goes something like this. So cookies marked with a secure attribute are only ever sent over encrypted HTTPS connections, and therefore they're safe from man-in-the-middle attacks. So the point here we're trying to do is we want to prevent someone on the network between the client and server from being able to intercept or get access to this cookie. So that's why we mark it with a secure attribute. So what do you think? Is this true or false? And hands up for true? Should be all hands. Why are you setting the secure attributes otherwise? Okay. Now, so again, this is both true and false. Depends how you look at it. So it is true in terms of confidentiality. So when you set the secure attribute on a cookie, you're telling the browser that this should only ever be sent over a secure HTTPS connection. So browser will typically honor that, and they will only send this cookie on an HTTPS connection. And that means that someone between the browser and the server won't be able to read this cookie. So that's all good. Now, the problem is it doesn't provide any sort of protection in terms of the cookie's integrity. So although Mallory here in between Alex and Bob can't read this cookie, can still write or change this cookie. So that's a very important thing to keep in mind, that you have confidentiality protection, but not necessarily integrity protection. So don't make any assumptions regarding the security of the content of that cookie. For example, it can lead to XSS if you had stored some information in the cookie and you think that no one else from you or the end user could change the content of it, because an attacker in between could write a new cookie and overwrite that one with some malicious payload that would then execute when that information is included on the page. It could also lead to issues in terms of process request forgery if you're using a double submit cookie pattern, for example. So for those of you who were at the OWASP London meeting, I think it was back in March, I did a presentation regarding some various ways you could defeat that. And from that, you remember that by overwriting this cookie, the attacker now controls the value that you validate against. So the attacker can also create a valid request with the right token and bypass that protection. So another thing where this could be effective is, for example, if you're not rotating or updating your session ID upon authentication. So I guess most of you have heard about session fixation, and it's basically an attack where an attacker knows the session ID and sets that for a user that then elevates the privilege from perhaps an unauthenticated user to an authenticated user in the system. And as the attacker knows this session ID value, they will now also be able to authenticate as that user towards the application. So if your application doesn't update the session ID after authentication and you're storing session ID in a cookie, this could be used to force a cookie upon a user that then authenticates and updates that session. Okay, so again, for those of you who want to see a demo of bypassing double submit cookie pattern, I suggest you go to YouTube and look up the presentation I did at AppSec in the US. We'll skip that today and move on to the next attribute, which is HTTP only. So this is something that was intended to prevent a cookie from being accessible by JavaScript, right? So this was something that I mentioned that Microsoft introduced first and all browsers support today. And the story goes something like this, that because cookies are marked with HTTP-only attributes, they're not accessible from JavaScript, and therefore they're unaffected if you have a cross-site scripting attack on your system. So again, is this true or false? Well, just like previously, you can probably guess that it's partly true. It does protect confidentiality, but it doesn't protect against integrity. So although in JavaScript, you can't access the cookie through document.cookie, so you can't read it. And if you try to write a new cookie through JavaScript with document.cookie on something that's marked with HTTP only, it won't actually stick. So you can write a cookie, but when you then try to read it and see what's in there, you will see that the previous cookie is still in there, and the new one you try to overwrite was not efficient. However, we can actually bypass this by overflowing the cookie jar. So all browsers, they have a limit set for how many cookies they can keep for each domain. So if an attacker is able to inject a script into your domain, they can start to overflow a cookie jar by writing a lot of cookies, like dummy cookies, and then once the original HTTP-only cookie is evicted from the cookie jar, they can now set a new cookie with a chosen value. So the integrity is not really protected in practice, although in theory it is, because you can't overwrite a cookie through document.cookie. So I have a very simple script I'm just going to show you. Switch here. So I'm not sure if it's big enough. Do you see? Yeah, hopefully you can see. So it's a very simple. Basically, it's like a small proof of concept to overwrite the cookie jar, and then to overwrite the HTTP-only cookie and then restore the previous cookies you had in there. So what I'm doing here basically is that I'm first storing the previous cookies. So I'm storing them in a temporary variable, and then I'm looping through and trying to set this new cookie that I want to overwrite the HTTP-only one. And every time I set it, I try to see and read out, was I successful or not? If not, I iterate to set a new dummy cookie, and then I try to set it again, up to max attempts. So in this case, I think I set it to 200, and most browsers will do it between 150 to 180, I think. So once I've done that, if it's been successful, then I will remove all the dummy cookies that I set and then restore the previous cookies that I stored in the variable. So let's try to see this in action. So I have Chrome here on the other demo app that I did for the CSRF bypass. So here we can see we have a connect SID, right? So this one is marked with the secure and the HTTP-only attributes. So if when I try to simulate that we had a cross-scripting attack, so it would run within this domain. So we can just check document domain, for example. So we see we're on this server, right? So now we simulate that we have a cross-scripting attack. So if I now try to read this cookie here, we see that we don't really get anything, right? So HTTP only works, it protects me from being able to access the value of the cookie. Now let's try to set a cookie. So if you say, type something here, that's document cookie, and yeah, had something in that last year. So let's set it to like, sorry. Let's check if it was the right name. Connect.sid. Connect.sid. Okay, so let's try to overwrite this cookie now. And if we now try to read it again, we see it's still empty. And if you look here and update, there's no new cookie, right? So we tried here to overwrite the HTTP-only cookie, but it was not successful. And that's due to the browser blocking us from accessing this cookie, reading or writing to it through the JavaScript. So now, just to see that we can set another cookie, let's set a different name. So if I write this one, we see that it's actually there now. So we're able to set this cookie with a different name. And if you look at the application here, we see we have a different cookie, okay? So we have these cookies now. So we were able to set normal cookies, but we're not able to overwrite HTTP-only cookies. So let's go back to our script here now, and let me just see if I manage to copy everything, and then just drop that down here into the console. And in theory now, hopefully, what it should do is should actually store these previous cookies that I had, and then it should try to evict the HTTP only cookie, and then overwrite the connect SID with a new value. So if you run this, we see that before it was only able to access this dummy cookie. Sorry, down here. And then we see after 179 attempts, it was able to overwrite the cookie and evict the previous one. And then we restore the jar. And this is because we had one cookie or two cookies before, and Chrome, I think it's 180 cookies you can store per domain. If you go back now to this one, we see that this cookie connect SID that was marked with HTTP only and secure before is now overwritten from our JavaScript. And the previous cookies that was there, I've restored that because I was saving it while I was flushing the cookie jar. So by using this technique of like overwriting and evicting cookies, you can actually tamper with HTTP only cookies. Again, I don't think the risk is nearly as bad as if you could read it in most cases, but there may be instances where overwriting content on an HTTP only marked cookie from a cross-scripting attack can be valuable. Okay. So the next one I want to discuss is the path attribute. So this is something that we sometimes see in some recommendations. I think even in some of the OWASP testing guidance I've seen. When we talk about, sorry, that was the next one, domain. Talk about that the path attribute is used to scope a cookie to a specific application. So we should try to, if we have two different applications, for example, on the same domain, then we could isolate them from each other by using the path attribute. So that if there's a vulnerability in one, for example, cross scripting, that would not be able to read the cookie of the other application. So it may sound good in theory, but if you think about this in practice, it's not really something that works. And the reason for that is that cookies are quite different from other things in the browser. So normally we have the same region policy that will prevent different domains and applications from interacting with each other through your browser. But the cookie scope is somewhat different. So if you look at the cookie scope, it's defined by the path and by the host or the domain that is set for. But if you look at the same region policy, it's using the host and the port and protocol. So these are somewhat similar, but they don't fully overlap. There are some differences here. And that becomes important if you have two different apps. For example, here we have app 1 and app 2, and let's say we want to try to isolate them from each other in terms of security. As I hope you know, this is not possible to do just by having a different folder where you host them on, if you're on the same server. Because even for cookies, if we can distinguish them in terms of the path that we set, they are not actually isolated. Because in terms of cookie scope, they are. So if I'm on app 1, I wouldn't be able to read a cookie scope to app 2 and vice versa. But through the client, because of the same region policy, they look the same. So with client-side script, you could actually make a reference to the other app on the same host, and you could grab the cookie from there. Okay, the last one of these attributes I want to discuss is the domain attribute. So sometimes we see recommendations like this, that you should set this domain attribute to be the origin host that you want to limit the scope of this cookie to. And for example, if you have your app on app.mysite.com, then it should be set to domain equals app.mysite.com. So is this true or false? Good recommendation or not? Well, it's certainly better to do this than to scope it to the parent domain. You've limited the scope, but it's not really always doing what you think. So you may think that you've now reduced the scope to only that host, but in fact, it's visible to that host and all its subdomains. So the risk here, of course, with subdomains is lower than if it was scoped to a parent domain, but it's still a relevant risk. For example, you may have different system, for example, may distinguish between dev, test, and prod by having different subdomains under your main domain. And anything you now scope to your main domain or to your production domain could be accessible perhaps in your test or dev environment. And I know for some companies, having production data accessible in a test environment is a big no-no. So in these cases, you need to be a bit careful with how you scope your cookies. And the best thing is actually to not specify the domain attribute at all. Because if you don't specify the domain attribute, it will be a host-only cookie. And in most browsers, except IE, unfortunately, it will only be sent to that host which set the cookie. Okay, another thing I want to talk about very briefly is cookie lifetime. So here's a quote from Wikipedia. It says that a session cookie, also known as an in-memory cookie or transient cookie, exists only in temporary memory while the user navigates the website. So is this really true or false? Well, I wouldn't blame you if you believe this, because this is something I believed for quite a long time until I realized that it's not always the case, actually. So it is true that it only lives is accessible and available as long as the session is alive. And the danger here is believing that the session is the same thing as your browser is open. Because of how browsers work, they can decide when the session ends, and it's not necessarily when you close the browser. And non-persistent cookies can actually survive a browser restart and perhaps even a computer restart. Because, for example, if the browser crashes or something else, you might have noticed that when you restart it again, you get this, do you want to restore session kind of question. And if you do that, it will retain all those session cookies that you had. And Mozilla actually explicitly warns about this, that if you have something sensitive in your cookies and you want that to be, you need to make sure that you eradicate that and expire the information and not rely on the browser to do that when you close it. So you shouldn't store anything sensitive that shouldn't be around for a long time in a cookie, because that could be persisted and potentially be accessible to someone even after browser restart. Okay, so that was some of the content regarding how cookies work today and how to look at some of the potential pitfalls that you could fall for. So what is happening in terms of cookie security, and can we make this better? Well, there are actually some work going on right now in 2017 to make this better. And this is an update to the RFC. So the first thing that you're trying to bake into this is what's called strict secure cookies. And remember before how I said that a secure cookie marked with secure could be overwritten through a non-secure origin through a man-in-the-middle attack. So this is what this is trying to stop. So what it does is that enforces that a cookie marked with secure can only be set from a secure endpoint, in other words, of HTTPS, and it can not be overwritten from a non-HTTPS origin. So that means that it wouldn't be possible to overwrite an existing secure cookie through a man-in-the-middle attack unless you would be able to get break the TLS connection, so to say. However, it's not 100% protection against setting malicious secure cookies, because attackers still has a window of opportunity to preempt these cookies with their own. And for example, this is relevant if you look at the CSRF protection, where you have stored a CSRF token in a cookie, because some frameworks then may rely on checking on if they get this cookie already. And if they get such a cookie, they won't set a new one. So if an attacker can first plant such a cookie, they can later exploit that to use that knowledge and bypass CSRF protections. The next thing in this new update is something called cookie prefixes. And the problem it's trying to solve here is that when we send the cookie from the client to the server has no way of telling whether that was a secure cookie or whether it was marked with HTTP only or any other attributes. So the only thing that gets sent to the server is the name of the cookie and its value. So the server doesn't really know where this comes from, and it doesn't tell anything about the security properties of the cookie. So the solution here would try to be backwards compatible by smuggling some of this information in the name of the cookie. And it's obviously not a beautiful solution, and even the first draft of that had a note about that. It's an ugly solution, but it's the best thing we can do without breaking things or introducing new attributes. So the two of these, the first one is called secure, and the other one is called host. And as security experts, we have not really done a good job of helping developers to get things right. And it was said before, like, we shouldn't blame the developers, because you would have thought that the secure one is not the most secure. So you would think that if you want to secure, you should use that one. So the host one is actually more secure because it's more strict. The difference here is that the secure prefix enforces the cookie to be set over a secure channel and to have the secure attribute set. So the server can now know by looking at the name that it's a secure cookie. The host one goes a step further by enforcing that this cookie can only ever be scoped to the specific host that set it. So you can't set a cookie marked with a host attribute and scope it to the parent domain, for example, to widen the scope of the cookie. And you also can't specify different path than the root path of the application. The last one of these is the same site attributes. And the problem here we have is that cookies are automatically sent with the browser when every request we make to the application for which a cookie was set. And as you know, this can be abused by attackers in various different attacks, such as CSRF, cross-site script includes, and other types of attacks where we rely on the fact that the browser automatically submits this information. So the solution they came up with here in the same site attribute is basically to apply this attribute to cookies to tell the browser that this one should not always be sent. They should only be sent when a request was initiated by the same site, by the same origin. So that is trying to prevent these cross-site request forwarder attacks where another region could initiate a request to your site and thereby fool your browser to include a request to make it look like you initiated it, when in fact it was just another site you happened to browse by. And the two different modes of this, I'm not going to go into details. I recommend you read up on it if you want more information on that. But it's basically to prevent these cross-origin requests from attaching these cookies. So it's something you would put on your, typically your session cookie. Okay, so that was a quick run through of this. So let me just briefly end with some key takeaways here. So the first one I want you to be aware of, if not already, is that cookies are still largely based on a draft from 1994. So it's a very old recipe we have, and it has a lot of security weaknesses and flaws that we need to be aware of. And knowing this hopefully helps you to not build your applications with false assumptions regarding cookies. Especially I want to point out that the integrity protection of cookies is very, very weak, and you should never rely on the content of a cookie not having been modified by a malicious entity. Be very careful with that. So don't trust your cookies blindly. And the last thing I want to point out here is that application and framework developers should really start to take advantage of these new improvements. So some of these are already supported in browsers. For example, Firefox and Chrome both support strict secure cookies and cookie prefixes. And same site is also starting to get support in browsers as well. So there's a lot of good things happening, and I hope that within the next year, this will be standard across all modern browsers. And this is something that we should start to implement in our applications, in our frameworks, for example, default to these host prefixes, and make sure that we tighten up the security around the cookies. For now, though, be aware of that not all browsers work the same, and you should not rely solely on these mitigations yet. So, for example, I wouldn't recommend anyone to just add the same site to your session cookie and then don't care about cross-request forgery, because you might still have users that would be vulnerable. Okay, looking at all these new attributes and things we can use for cookies, is there something like a ultimate cookie that would make us the most secure one? Well, we don't have anything that protects against everything, but this is probably as secure as it gets right now. So what we can see here is that we first off use the host attribute. As I said, you will now restrict this cookie to a specific host, so it's not shared across a parent domain, for example. And also that implies that you need to set the path to the root and also set the secure flag, so it can only be set over a secure channel. The next one is HTTP only, which means that this cookie can't be read by any JavaScript. Unfortunately, as we saw before in the demo, we can still overwrite them by evicting cookies, but a JavaScript can't read the content at least, so we have a confidentiality protection from cross-scripting. And the last one is we use the same site with a strict mode, which enforces the browser not to send this cookie unless a request was initiated by the same origin that we are making the request to. Okay, that was it. Any questions?
Okay, let's thank David for his talk. Right. As usual, Bristol guys have priority. So guys in Bristol, do you have questions for David, please?
So when you're going through and overflowing the cookie jar, could an argument be made that any cookies which are set via JavaScript do not replace the ones which have already been set by HTTP only?
Yeah, definitely. So actually, that's what they're doing for the secure ones, right? So from an unsecure origin, you can't overwrite the secure cookies, because you could try to do the same to evict a secure cookie, but specification prevents that if the browser supports strict secure cookies or the new HTTP update to the cookie specification. In terms of JavaScript access and overwriting HTTP-only cookies, there is no such thing yet. It's funny that you mentioned, because I actually today filed an issue on the new draft specification pointing out that they should add that. So hopefully they will pick it up and do something about it, because I can't see any good use case for when a JavaScript should be allowed to evict HTTP-only cookie.
Yeah, great. Thanks. Any questions, guys? I also put the slider. Don't forget to use the app to ask your questions, because the speakers will answer them after the event as well. More questions from Bristol, please.
Everyone looks happy, so questions in London, I guess.
Before we start questions in London, I'm going to use this cool microphone, which I can throw, right? So if you raise your hand, I'll just throw the microphone. There's a little cross here, and you can speak into it, okay? I just need to switch it on. Hello, hello. Okay, questions.
What's your head?
Where is it?
All right. So I had a question on the integrity, right?
Yeah.
Because you kind of meant that when you use a secure, right, you can compromise the integrity. So that one is a bit confused, right? Because I was under the impression that Excel provides also integrity. So you're not meaning that you can actually put values in the man in the middle, correct?
You can do that. So it depends which browser you're using now, because as I mentioned at the end, that Firefox and Chrome this year, they started to implement the strict secure cookie, and that is what prevents you from overwriting a secure cookie from a non-secure origin. But in other browsers, not supporting
so you're saying that you can write it on HTTP, right?
Yeah.
So when you are in HTTP, you can overwrite the HTTPS one. Is that what I mean?
Yes.
But not in the middle. You cannot change this.
No, I don't mean that you man in the middle HTTPS connection.
Yeah,
but
okay,
what I mean is that what you can do is that for any website, any browser basically, if a user is browsing any page on HTTP, what an attacker can do, if you're a man in the middle on the network layer, you can intercept that request, and in the response from that HTTP request, you can inject some content that would generate a new HTTP request towards the target site that you want to overwrite a cookie for. So even if that target site doesn't listen to HTTP at all, the attacker will still be in between, right, when the browser generates that request. And the attacker could respond with something and then set a set cookie header in that would then overwrite the secure cookie.
But if you have the HTTPS header, then that is not possible.
Yes, so that's a protection against that. Yeah.
Or if you have the web application firewall too.
So
because general integrity is protected by the web application firewall.
Yeah, question on WAF, whether that will protect?
Not sure it would. It doesn't protect you from being able to overwrite it as an attacker. It depends if the browser, if on the other end, if you compare it with what was set, then maybe you can detect that a change has taken place and you can do something about it. But the overwriting it as such doesn't help. Yeah, I mean you can detect. Yeah, if you check if it's changed, you could check that. Yeah.
So,
oh, you mean if the WAF is working as a reverse proxy and it will act as a filter? Okay.
All WAF have to be a proxy in the middle, and so it's mandatory for that to inspect the request. It's the reason why the first statement about the fact that somebody in the middle get prevented. No, because an attacker on local could also create a host entry on the host.
I thought, regardless of SSL, I thought you were suggesting that a JavaScript attack could also compromise the integrity of the cookies. Wouldn't that require an XSS attack, unless you were trying to do a attack. You'd have to have an XSS in order to execute that, though, right?
Yeah, so that was targeting the HTTP only attribute, right? So the context was HTTP only. What does that protect against? So we all know that it protects a cookie from access through JavaScript. That's the purpose of it. But what not everyone is aware of this, that you can still overwrite such a cookie from JavaScript. So if you have a cross-scripting attack, you're not safe in terms of integrity of that cookie, but you're safe in terms of the confidentiality.
Yeah, exactly.
Yeah.
Yep.
Any more questions? Jeff has the microphone. No more questions? Right. Okay. If there are no more questions, I'm going to finish with the last finishing things. So can we please thank our presenters, Jeff Williams and David Johnson? Can we please thank beer and pizza and Kevin Fielder, the CISO, sitting on the table over there. Thanks, Kevin. Okay. So we're going to go to this pub now. All right. Let me, can you see the pub? Where's the pub? I think I'm sharing the wrong page. 1 second. Let me share the pub information. Pub. Right. Okay. Can you all see the place where we are going now? This is the place. Okay. So we're going to continue until 11 p.m. the pub closing time in here, the Viaduct Tavern. You exit this building, you turn right, you will see it. So next meeting is on 25th of January. Please follow us on Twitter, Facebook, and subscribe to mailing lists. Those of you who are members, I will give you the stickers. There was a question, so all the presentations will be published on the OWASP website in the next couple of days, and hopefully the live stream will be on YouTube. Thank you very much, guys. Thank you.
London, that's it.